Good afternoon or good morning, friends from all over the world. Thank you so much for joining us on this global forum. The topic that I would like to share with you today is bioacids and poultry liver health. If you have any questions, feel free to send it to the talking box. After I finish, I will answer you as soon as possible. Well, first of all, I would like to see liver is a silent hero for poultry. In fact, not only for poultry, but also for humans. I would say for humans, the liver is also a hero. This is because, a healthy liver is essential for maintaining a healthy and productive poultry, because the liver is involved in metabolism, digestion, and detoxification, and many other functions. Well, firstly, liver is a master of metabolism because, in here, fats, sugars, vitamins, protein, and hormones are metabolized. Secondly, liver is a warehouse. This is because, glycogen, protein, fat, and blood are stored in the liver. Thirdly, liver is a detox specialist. This is because the liver is the largest detoxification organ, where decompose and oxidize toxic substances. Fourthly, the liver is a defensive shadow. This is because it has rich lymphatic system and immune cells, and also produce antibodies such as IgA, G, IgM, etc. Fifthly, the liver can also secrete bile and clotting factors, so supporting and protecting liver function is the key to maintaining growth and production performance of poultry. However, I would say the liver is a really easy target for all of the toxins because, it's just like I said before, the liver is the largest detoxification organ in animals. Poultry and poultry feed are often contaminated with multiple mycotoxins because, many moths grow on the same time under similar conditions and produce different mycotoxins. And here I would like to introduce what are mycotoxins. So mycotoxins are secondary metabolites produced by fungi in the plants before or after harvest. A large percentage of the agricultural production worldwide is contaminated by at least one mycotoxin. And mycotoxins can contaminate or kind of raw materials, feed ingredients, and also cause significant damage to animals' health and production. And it's said that, the global mycotoxins survey reports that more than 85% of animal feed samples from 100 countries are contaminated with mycotoxins, mainly, AFB1, DON, T2 toxin, and OTA. And in this page, I would like to talk about clinical symptoms of mycotoxins. Intoxication. There are the types of mycotoxins. You can see aflatoxins, OTA, T2 toxin, fulmosins. So these are the species of mycotoxins. And here, there are the effects of mycotoxins on poultry. Well, first of all, the effects of aflatoxins. Well, for example, hepatic injury, body weight reduction, losses of appetite, and also, disorders in the central nervous system, and also leg weakness. As well as blood clotting disorders, and also disorders in metabolites of vitamin B and also amino acids, as well as losses of defenses. So these are the effects of aflatoxins. And then let's see the effects of OTA. So, well, first of all, it can cause kidney damage, and also, increase the water intake, and also poor quality of eggshell. This is mainly for laying hens, and also reduced feed intake and decreased egg production. And this is also for laying hens. Next, let's see the effects of T2 toxin. I think, lots of us are very familiar with these toxins. Well, first of all, T2 toxins can cause lessons and also reduce the egg weight. This also for laying hens, and as well as increase the number of poor quality of eggshells, and also decrease in shells also for laying hens. Finally, there are the effects of FB1, FB2 toxins. Well, first of all, reduced body weight, lower daily average weight gain, increase the gainer weight, and also increase the mortality in poultry. And this is mainly for broilers. So mycotoxins must be controlled to ensure liver health and poultry productivity. I think the problem of mycotoxins must be paid attention to. How mycotoxins be prevented and controlled to protect the liver health? Well, first of all, I think you'll need to reduce mycotoxins at the source. I recommend you to purchase high quality feed raw materials. Mildew raw materials cannot be used, and do a really good job of cold warehouse management, reasonable planning of raw material use. Feed a small amount each time, add frequently. Feed at least maybe 3 times a day to prevent the feed in the tank twice mildew. And then you have to reduce the amount of mycotoxins entering the blood. You can use mycotoxin absorbents and degradants to deal with the toxins, in the feed or in the feed additives to the, greatest extent, and then reduce the part that enters the blood. Finally, I think you have to protect the liver and remove toxins that accumulate in the blood and liver. Well, just like I said before, the liver is the largest detoxification organ in the animal body, in poultry body, in our human body. While reducing mycotoxin intake, it's really necessary to enhance the liver function of poultry, stimulate the liver to secrete detoxification enzymes and help the liver detoxify. Most of the mildew remover treat feed mycotoxins through physical absorption and biodegradation to reduce the mycotoxins entering the animal body. However, no matter how perfect the mildew remover cannot guarantee 100% of the mycotoxins in the feed. There will always be a part of the residue into the blood circulation. Some additives can also be used to protect the liver. For example, some additives with antioxidant and liver protection can be added to the feed to stimulate the liver to secrete a large number of detoxification enzymes, remove toxins accumulated in the blood and the liver, reduce the damage of mycotoxins to the body, and also improve liver function. And here I would like to inform that some studies, a lot of studies have shown that bile acid can inhibit the growth of mold. The name of our product is Renew. It contains bile acid. Okay, bile acid can inhibit the growth of the mold, activate the expression of xenobiotic detoxification enzyme gene in the liver. Improve the efficiency of clearing mycotoxin and reduce the oxidative damage of toxin to animal body. Well, next, I would like to show you a couple of scientific articles on how bile acids improve mycotoxins. I mean, why bile acids can alleviate mycotoxins. Well, the first article, this article, the name of this article is Effects of Bile Acids on T2 Toxin, Xenobiotic Metabolism and Toxicity in Broilers. Well, it's a pity that this is a Chinese word. Simply introduce the conclusion of this article. This article told us that bile acids can activate the FXR signaling pathway in the liver. So FXR is a funny salt X receptor. it's a link between bile acid and also, lipid metabolism. So after FXR signaling pathway is activated by bile acids, it can improve the expiration of liver metabolism and foreign body metabolism enzymes. For example, CYP3A37, you can see that these foreign body metabolism enzymes, the activity of foreign body metabolism enzymes were improved after adding bile acids. So this can accelerate the detoxification efficiency of T2, toxin T2 in the blood and protect the integrity of liver cells. And this study also found that bile acids can increase stress residence and relieve oxidative stress. From pictures C and D, these two pictures. From these two pictures, we can see that bile acids significantly reduced liver enzyme elevation caused by T2 toxins, mainly ALT and also AST. So this is the ALT and this is the AST. These two enzymes are commonly used in clinical practice as indicators for assessing liver function and also, detecting liver damage. When liver cells are injured, these two enzymes are released from the cells into the bloodstream. You can see the levels of these two enzymes in the bile acid group. So this is the bile acid group are significantly lower than those in the control group. This one and this one are the control group. If the levels are too high, it can cause oxidative damage to cells. The activity of and also bile acids can significantly decrease H2O2 level. This is one of the most common oxygen-free radicals in vivo, and also the CAT level in broilers. So from picture F and G, you can see that the activity of CAT decreased. So also these two groups are control group, and these two groups are the bile acid group. The activity of CAT reflects whether the organism or cells are responding to oxidative stress. The CAT level in the bile acid group were not as high, indicating that the cells or tissues of the broiler didn't experience intense oxidative stress due to bile acids. And also from picture H, this is picture H. You can see that bile acids significantly increased the level of SOD here. SOD is a really important antioxidant enzyme that decreases, super oxides to protect the liver. Protect liver health. Okay, this is the first article that I would like to show you. And the next article that I would like to show you was already published in the journal, and the name of the journal is called Toxins. It's already available on the internet. So I would like to say friends who interested in this article can search for it to read it, or you can also leave your email to our talking box. I will send it to you, the whole article. So let's see this article. This is this picture shows the experimental design of this article. In this experiment, 5-day-old broiler chickens were used. They were randomly assigned to 3 groups. This group is the control group. CON group is the control group, and AFB1 group, they received a basal diet, and also AFB1 plus BA group. So in this group, the chickens in this group were received a basal diet with 250 gram per ton bile acids for 20 days. After 3-day pre-feed, AFB1 and AFB1 plus BA group, the broilers in these 2 groups were daily AFB1. But the control group received FB1 treatment. So this is basically the design, the experimental design of this article. And here you can see that bile acid alleviate AFB1 induced oxidative damage and inflammation in the liver. In particular, the level of the SOD, you can see it from this picture. The level of the SOD increased after adding bile acids. So this is the group with bile acids, which has the effect of clean away free radicals, anti-inflammatory, and antioxidant. I mean, SOD has the effect of clean away free radicals, and also anti-inflammatory and antioxidant. Okay. And here you can see that bile acids decreased serum AFB1 and AFBO levels. So from these two pictures, these two pictures you can see it, but increased bio AFB1 and AFB2 levels. So from these two pictures, you can see that the AFB1 and AFBO levels increased. The transformation of AFB1 to its metabolite AFBO was improved with accelerated excretion to the gallbladder and serum. Bile acids alleviate AFB1-induced decline in liver detoxification enzyme activity and also excretory function. These are the enzymes. I already talked about it before. These enzymes are hepatic xenobiotic metabolizing enzymes, also known as liver detoxification enzymes. After the addition of bile acids, the activity of these enzymes, the level of activities of these enzymes are all enhanced. So that's why bile acids alleviate AFB1-induced decline in liver detoxification enzyme activity and also, excretory function. These pictures told us that bile acids can alleviate AFB1-induced liver LXR alpha decline, and also, dietary BA supplementation improves hepatic AFB1 detoxification and also excretion through LXR alpha involved regulation of xenobiotic enzymes. Here, I would like to explain what is LXR alpha. So this is a key transcription factor for the activation of hepatic detoxification enzymes and also xenobiotic transporters. Upon activation, it participates in the transcription of the multi-drug resistance associated protein 2 gene, which is involved in the habitobiliary excretion of endogenous and exogenous compounds. And this is the conclusion of the article. Bile acids can promote the metabolism and excretion of AFB1 in broiler chickens by regulating enzymatic reactions, including XR alpha, thereby reducing AFB1-induced liver oxidative stress and also inflammation. That's all I would like to talk about for today. Thank you so much for listening. If you have questions, you can put it in the talking box. I will answer you.
Okay, thank you. Thank you, Ms. Tracy, for your enlightening speech. And here I think I get questions from the audience. The questions is, how much bile acids can be added to improve liver toxification and mycotoxin excretion?
Well, for this question, our recommend dosage is 200 grams per ton. In fact, to protect liver health and improve liver detoxification of mycotoxins is only one of the functions of bile acids. Bile acids can also reduce feed costs and improve the growth performance of broilers by increasing the utilization rate of oil. Normally, it can reduce $2.25 per ton of feed after adding bile acids, and can also increase the the weight gain of broilers by 5% and also reduce FCR by 0.03 to 0.05 and reduce the abdominal fat percentage by around 20%.
Okay, thanks for your answers, excellent answers. And I think we also get questions from Mr. Shamakumar Das. His question is whether bile acids is a chemical or natural source.
We extracted bile acids from poultry bile. So I would like to say bile acids is the natural source. Sorry.
Okay, thanks for your answers. The bile acids is from the raw materials from the poultry, right?
Yeah.
And it's certainly is a natural source. Okay, thanks for your sharing. And it's encouraged every audience, if you have any questions, you are welcome to ask in the chat box. And we also get another questions from Mr. Sain. Can we reduce the other antioxidants while using bile acids?
Well, for this question, I would like to say after adding bile acids, you cannot reduce the antioxidants in the feed. Or I mean, because for oil, it's very easy for oil to have the problems of oxidants. So to be honest, after adding bile acids, I don't recommend for you to reduce antioxidants in the feed.
Well, thanks for your answers, and hope Ms. Tracy's answers can fit your needs and is helpful for you. And for other audience, if you have any questions, please feel free to ask.